So this is probably one of the most frequently asked questions when you're talking about active harmonic filters, and that is, why do you need a line reactor in front of the active filter, and why does my harmonic current increase out of my loads when I add an active harmonic filter? So to answer the question of why I need to oversize my active harmonic filter because the harmonics that are produced by the loads are actually going to increase, let's talk about what actually is happening. So we're going to put on just a single drive and look at the harmonics coming into the system and the harmonics right at the drive. And then in between those two, we're going to put on an active harmonic filter, show how the source goes down. We reduce the harmonic currents by injecting equal and opposite harmonics. And then we're going to look at the load right at the drive, and we're going to see how much that actually increases a little bit, and I'll explain why that happens. So let's first of all start up the drive, and we'll run it and take a look at the harmonic current. So right now we're looking at phase B on the harmonic current of the fifth harmonic current is 13.6 amps. And if I look at my input to my drive, it's basically the same on the input to the drive. So now I'm going to turn on the active harmonic filter, and what you'll notice is on the incoming service, of course, the harmonics go down because we're injecting equal and opposite harmonics. But now you can see that the harmonics at the drive have actually increased a little bit, over 15 amps now. So we've actually increased the harmonics coming out of the drive by adding in the active harmonic filter. And the next thing I'm going to do is add in a line reactor in addition in front of the drive and show that with that it dropped down the fifth harmonic current to about 8.6 amps. And now I'm going to turn on the active harmonic filter, and with that additional larger reactor, of course, the incoming looks good, but the output or the input to the drive looks almost the same. So let's talk about that for a minute and see why that actually happened. So again, what we had was we have our source transformer. We have a busway here where we have an active filter here, and then we have our drive, our VFD here, feeding our motor. Now, the first time we had a certain amount of harmonic current coming this way, a fifth harmonic, and it was on the order of 13.2 or something amps of fifth harmonic current. Okay? And then if we measured over here, we had roughly the same, 13.2 amps of fifth harmonic current. And then the next thing we did was we put on the active filter, and this kind of went away because, of course, what we're doing is injecting equal and opposite currents. So when we do that, if I could draw straight, this actually injects current. What it's doing is injecting it toward the load, and by doing that, it negates what's going back to the source. Because remember, the harmonic current comes from the load and flows back out onto the system. So why does the harmonic current increase to 15 point something here? I think it was like 15.4 amps. Why does it increase when I put that active filter on? Think about it this way. Essentially, we're drawing that harmonic current down through the system and through this thing here, which is a transformer, but essentially a reactor. If I'm shorting out this reactor by putting my source of current right here at the active filter, I don't have to flow that current down through here anymore, okay? I can just have that current flow right to the load. And so therefore, the drive itself is not constricted like a line reactor would do, and so I can actually draw higher current. So what I did in the second example was added in this line reactor here, and by adding a line reactor here, we actually first of all reduce this down in the beginning to something less than 9 amps. And then when we put the active filter on over here, and we had a change, obviously this went to 0 on this side, but this stayed at about 9 amps. So again, pretty common question that we get regarding active filters. Why do I need a line reactor? You need a line reactor to stabilize that current going into the drive so that the active filter doesn't increase it by shorting out essentially the source impedance. And then why does the current increase? Just for that reason, because we're shorting out the source impedance, which essentially is constricting the flow like a line reactor normally would do.